Hey, this is Mr. Mitchell with another video. Today we're going to talk about power. Go ahead and write down the questions and let's see what power really is. You know, whenever we think about power, we think of lots of different things. Could be a power button, the phrase knowledge is power, even strength like this strong little kid, or clenched up fist, or guy lifting weights. But power, of course, is a specific quantity in science that has to do with both work and time. So, the power formula is power equals work over time. So, let's think about this. You know that work involves something done. You have to have some kind of movement to have some kind of work. For example, you may remember the guy pushing up against the wall. The guy pushing up against the wall didn't do any work because there was no movement of the wall. So power involves actually having motion, which is work, and the amount of time it takes. Let's take a look at these swimmers down here. All of these swimmers are doing basically the same amount of work. They're going from one place to the next, and the one that does it in the least amount of time is the one that will actually have the most power done. So it's similar to your concept of power of strength, because you do have to utilize your power in order to get things completed in a certain amount of time. Power is going to be in joules per second. You may remember that work is in joules and time is in seconds. Now, on occasion, you'll have a formula that looks like this: power equals force times distance over time. You may remember that work is force times distance. So if you are given the force and the distance and the time, you should be able to figure out the power. Now, of course, everything we have studied seems like it has a whole different unit. And sure enough, when you calculate power, you calculate it in watts. Joules per second equals watts. So let's look down here and see what our problem will be. Amy uses 20 newtons of force, so newtons is going to be force, to push her lawnmower 10 meters. Meters is going to be distance in 5 seconds. So in this case, we had to calculate the force times distance before we can learn the power. Okay, so that means power equals force times distance divided by time. So what does that mean? We have power equals force is 20 newtons times distance, looks like it will be 10 meters, and that will be divided by 5 seconds. So that means now that power can be reduced down to 20 times 10. I have a feeling we can do that regardless of whether we have a calculator or not. That'd be 200 is 20 times 10 divided by 5. Oh, that works out pretty well. So power equals, let's see, 20 divided by 5 is what? 5 into 100 will be 20. So 5 into 200 should be 40. And it would be 40 what? 40 watts is what it would end up being. So that's how you would calculate power. Let's go to the next slide. Let me tell you a little bit about this guy named James Watt, and you can probably figure out that the term watt came from him. He didn't intend to really have much to do with the light bulb. As you probably know, that's kind of why where we hear the term watt a lot is light bulb. For example, this is a 150 watt light bulb. But no, he was not really an electrician. What James Watt did was to make a better steam engine. Now, he didn't invent the steam engine. The steam engine was even decades, centuries in the making back in the 1800s, but he invented what looked like this. This was his steam engine. And in order to market his steam engine, he wanted to be able to tell people how much power it used. Remember, we're finding power. So he actually came up with the power formula, and he observed horses to try to figure out how much power horses had. And this is quite a powerful horse here. But he observed horses and took some calculations, and he came up with the term horsepower. And by his calculations, just by observation, he estimated that one horse had the power of about 746 watts. And you know, watts is joules per second, and you can break that down into Newton meters per second. So that's where he got it. He was calculating the newtons, and then he was able to calculate the meters, and then he had over a certain amount of time. And his steam engine had 10 horsepower. So he could tell people that this steam engine had the power of 10 horses. And in today's era of modern cars, you know, 10 horsepower is nothing. But back whenever James Watt lived, that was probably quite impressive to say that your steam engine had the power of 10 horses. So he became famous for his power formula, and I imagine he sold a few steam engines as well. Now let's talk a little bit about the light bulb wattage. By saying 150 watts, here's what that means. A 150 watt light bulb requires 150 joules of energy every second to shine its rated brightness. Whenever somebody buys a 150 watt light bulb, they're expecting it to be pretty bright. That's pretty bright as far as light bulbs go. So every time you plug in a 150 watt light bulb, you're expecting to have its rated brightness. So the filaments inside the bulb are going to allow 150 watts to go through, and that will, well, let me turn that again. 150 joules of energy to go through every second, and that's what it turns out to be with watts. Hey, we've been over several formulas this video and the last couple of videos, and lots of units. See if you can figure these out. They're not just from this video. But what is the units of force, work, power, energy, and pressure? Might be a good time to pause the video and see if you can figure it out on your own before I tell you the answer. Okay, let me tell you some answers here. We have unit of force. Why, that would be the newtons. Unit of work is joules. Unit of power is watts. Unit of energy, well, it's not Pascal. You may remember that energy and work have the same unit. They are both in joules. The unit of pressure would be Pascal. If you didn't do well, maybe you'll do well by the next time you see it in class. What about these formulas? Do you remember these formulas? Go ahead and turn off the video now and see if you can match them up before I tell you the answers. Formula for force is F equals ma. What about kinetic energy? That is 1/2 mv squared. Pressure. Pressure is force divided by area. Power. Power is work over time, which means gravitational potential energy is m mass times gravitational constant times height. Hey, I hope you've not only had a good review, but I hope you learned a little bit about power as well.